5, 4, 3, 2, 1, go! First project of Biomechanical for Engineering, Cycling Biomechanic. Sport biomechanical is a discipline that studies the forces developed by the muscles applied to the bony levers of the athlete. It's a science that seeks to perfect the human machine to obtain the maximum performance in the sporting gestures. Biomechanical is a legal and effective aid at the service of the athletes and can be considered as a no-doping technique. In short, any alteration in the coupling with the bicycle can generate, at the level of the ligaments and the supports, tension and abnormal pains that constitute possible sources of inflammation. Therefore, incorrect posture of the bicycle, maintained for a long time, can alter the normal sporting gesture and producing pathologies that will be necessary to diagnose and treat correctly, as well as worsening the speed and efficiency of the cyclist. It is to be understood that most the recreation cyclists and some of the professional present alteration and abnormals mainly in the proper execution of the pedaling gestures, because of the maladjustments present in front of the machine. It should be noted that the bicycle in the cycling is customized to the Missouri seek to improve the efficiency of the athlete and to establish the most ergonomic position, terribly seeking to reduce the incidence of sport injuries due to poor accommodation of the athlete to the machine and minimize the possible reductions that might exist due to the constant repetitiveness that present the execution of pedaling gestures. More and more people are using bicycles for sport, walking or a regular means of transport. It's only necessary to look around in any street to realize how easy it is to rent a city bike or see how many people practice sport on it. Being an unstoppable fact that does not follow a fashion and was a benefit hard clean board for the environment and health is a recommended as an excellent cardiovascular exercise. For this purpose of this project, we will only focus on the biomechanicals for the cyclists, but further let's talk about generalities about the movement of the legs, the joints tandemly at within the pedaling, and the acceleration or speed that they generate on the pedal. What injuries can occur? Long bicycle frame forces the cycler to be in a more horizontal position. Short bicycle frame forces the cycler to adopt a more vertical position which can use lumbago. High bicycle frame creates a hypertension of the kidneys which produces an overload in the posterior musculature. Low bicycle frame causes an overload of the extensor musculus. Excessive internal rotation of the foot. Overload of the external musculature and biceps. Excessive external rotation of the foot causes overload of the tendons of the internal region of the kidney and tendons of the gauze foot. Misalignment of patella. Pain in the patella causing patellar chondromalacia. Incoherent saddle height and position. Lumbar spine saddle to hit and the foreback causes pain and the patella. The pedaling consists of two phases that will be explained below. A first phase guide power which extends from the point of degrees or initial position to make half or turn of the crank and reaches 108 degrees. A second phase of recovery which extends from 108 degrees to reach 306 degrees. Return to starting position. Understanding that this phase of pedaling understand that the participation of different muscular groups during the pedaling gesture. Taking into account that the degrees of travel that each joint executes in the different moments of pedaling phase are the product of transmission of forces that the joints such as the ankle and foot are completely different from joints such as the kidney. This study used the lemon method in order to determine the ideal saddle height and to correlate this height with the position and angles of the crank of the time of placing the crank at 108 degrees, obtaining a result the ideal angle for the neck join the angle allow of the cyclist to achieve great economy of pedaling when the ranges of motion range between 30 to 40 degrees.
I will explain a little about the methodology used in this project. We use a woman who is 1.68 meters with an age of 21 years and a weight of 70 kilograms. We use clothes that were simple to let us evaluate the desired points of the ankle, knee, and hip in the enrichment and skill inspector software. We will also use an exercise bike, which will place it at the right height so that it can be used correctly. In the images, we can see the pedals, the seat, and the pedaling movements on video for subsequent analysis under the aforementioned software, where will be obtained the results of the different joints according to the pedaling of the subject. First, the subject will be placed on the exercise bike to start pedaling. It will begin with the positioning of the metacarpal joint on the pedal to start with the momentum of pedaling on the bike. Then you can see the resting position of the leg that gives us a flexion of 30 to 40 degrees. We will also use Excel to convert the points of the frames into tables in order to get the time and make the graph that are requested. To be able to use this software, it is necessary that we convert the videos in AVI format, so that is compatible with the program and it is possible to carry out the procedures. Once the video was opened in the program, we were placing the points every 5 frames with a total of 50 frames in the whole video. To explain the results, it is necessary to mention that to get the acceleration graphs, we only use Scale Inspector software because this way the graphs that we are going to evaluate are more specific. The first thing we did was to get able a table where we obtained the time that was obtained by dividing the frames by 30, which are the revolutions at which our cell phone take the video. After that, we obtained the linear velocities of the ankle, knee, and hip in the axis of the x and y, so we could see that the knee has the highest speed, then the ankle, and finally the hip. This is because the knee undergoes a movement from top to bottom continuously. Now, to decipher the accelerations was a little more complicated since the three accelerations were so similar. But observing the graph in detail, we noticed that the ankle begins with a maximum acceleration, like the knee. The hip did not present as much acceleration as it was more neutral. This is because at the time of pedaling, the hip does not move as much as the knee and ankle. Now, we will analyze the positions of the ankle, knee, and the hip in the axis of the X and Y. When we analyze them, we can see that the ankle is the one that has more movement. This is because the movement that makes it circular, what makes it has value in the axis of the X and Y, not like the hip that does not generate a great movement or the knee that only shows the movement in the axis on the y do the movements that makes up and down. Now with the ankle we can see the angular acceleration and angular velocity. This is known as the change in velocity per on time. In conclusion, cycling's positions on the bicycle and the activity of the muscular groups in each pedal stroke will determine the sport performance. The position of the foot in the pedal and the pedal stroke rate will also take part in the better profit of muscular power. Through the bibliography research of the analysis with the software, we realized the anthropometric needs and ergonomic limitations to achieve the perfect pedaling. From the beginning of the research, we put into consideration the height of the subject, his age, and previously knowledge of the correct positions of his body on the bike to achieve the best stride of pedaling. We realized that the physical properties of the bicycle must be adjusted of the height, building, and position of the subject. On a stationary bike, it is easy to make these modifications, as was your case. But in the outdoor world, whether for professional cycling or just recreational cycling, it is an arduous task to find those characteristics with a bicycle. We refer to accommodate the height of the seat so that when extending our legs, leaving the metacarpal joint in the pedal with an angle close to 0 degrees, while the extension of the knee gives us an angle between 30 and 40 degrees. If these requirements are not met, the subject in its pedal stroke will make a greater effort of overextension to reach the pedals, causing injuries in the muscle or joints. Also, it is necessary to denote the position that adopts the body of a cyclist considering that this one has the bicycle ergonomically adjusted for him. The position of the hands on the handlebars from an angle from 90 degrees to avoid the fatigue of the large muscles of the arms. In addition to give him a correct sitting position on the bicycle saddle. So we conclude that it's necessary to know and master these subjects not only for medical reasons but also for culture and avoid injuries. Also giving attention for the best pedaling in the sports environments or less training of stressful ones for recreations. Maybe the analysis lasts a few seconds and we repeat a few times to appreciate the movement.